Cool. Oh,
So, code splitting.
yeah, well, it's nice to be back, first of all. I think that's the first thing to say, isn't it?
It's been a while.
It has been a while. Thank you for joining us, if you are joining us. If you're watching this after the fact, then it's nice to have you do that too, I guess. But nonetheless, we are back. We're going to do code splitting. You're doing the coding.
I am.
I'm going to be on the live chat, which again, if you're watching this after the live stream, I mean, the live chat's not going to be there. So what are you missing out on? I don't know. Ooh, we're going to find out. So there's lots of people already saying hello. So hello back to you.
Amazing.
So it's nice to see you all there. Right, code splitting. Seriously, joking aside, what are we talking about today?
All right. So I guess I should start with showing where we're going to start with. So I grabbed our old router example code where we have a little website with like 4 subsections that you can navigate to. And we have like little nice transitions and all these things. And I updated it a little bit to use the new ES6 module goodness.
OK, so these are like the import statements, right?
Exactly. So
that probably needs to be a little bit bigger, I would imagine.
Yes, I should zoom into DevTools. Let's do it like this.
There you go.
I think I caps locked.
Oh.
OK, so if we're going to reload, we see that it's loading the view, the router, and the app. And if we navigate, it's going to load some additional code. So that's like lots of code being handled.
We've already got the very first question, which is there a service worker?
There's not.
So OK, so we had a service worker before.
We built a service worker at CDS, I think, for this website as well. I removed it for this example.
OK.
Because it's mostly just going to interfere. And today I mostly want to talk about the buzzword that is code splitting. Really.
Yes, it is actually a bit of a So code splitting and root-based chunking actually.
Very, very much intertwined. They belong together, but
yeah, because my understanding is that code splitting is you're going to send like one big bundle, and the code splitting is you don't need to send one big bundle.
Yeah.
You can actually break it down into other bits and pieces, and then the root-based chunking is what are those pieces?
Yeah. So with the thing is, when you write your code with modules and you don't bundle them, then you pretty much did the code splitting because you never bundled in the first place. But most websites just do a big bundle. Like they bundle everything up with like Rollup or
Babel or any
Webpack.
of these. All of them. There's like
and have like their index HTML, their styles, and app.js or whatever that has all the logic, all the JavaScript.
OK. Yes.
But the point is that if you open a website, you don't need all the JavaScript. You just need the JavaScript for that specific view. And that's how you should split your code.
I see where you're going. OK, right. So let's take a look at the code, can we?
Yeah, sure.
Because I want to see what you've actually done, what you've changed.
So
to be clear, I've not seen any of this code yet. So I'm with you. I'm learning as we go.
So if you have seen the episode where we wrote the router, you will remember that we have a header partial where we have the header, the start of the body with a nav. We have a footer partial, which is fairly non-exciting. And then in between the header and the footer, we stuff the content wherever you're navigating.
Yes.
So for example, for the landing page, there's going to be our SC view custom element, which is the current view, and the JavaScript that is needed to boot up that view.
I see you've got type equals module.
Yes.
So this is what you were saying, that you've now switched this out for the ES 2015 modules.
Yeah, so all the code I'm writing today is going to run in Canary, because I'm using the modules. You will need Canary.
And a flag, right?
And the experimental web platform flags.
You can in Safari you can use it with it's unstable, isn't it?
It is.
Safari.
Modules are unstable in Safari.
And then Firefox.
So are custom elements. So this might actually just work without anything in Safari. Who knows?
Whoa.
I haven't tried that.
No, we should find out.
And this is a good point to mention. This is not going to be production code. And this is more important than ever before today.
Yes. So actually, one of the questions before we started the live stream is: are you going to be writing this code splitting stuff from scratch? Will you be using Webpack? And I think the answer is we wanted to get into the nuts and bolts of what the code splitting is doing, like to demystify what's actually going on.
Code splitting? How do you do it? So yes, I am going to write it from scratch. But what's going to fall out at the end is not something that is completely generic and that you can just throw at your code base.
No, and there are plenty of tools already out there that do code splitting. What we wanted to get at is, if for some reason you weren't using one of those tools, you might want to, but you might also just want to know how this stuff happens and how, well, the rough ideas, the concepts behind it. Anyway,
I'd like to think we are educational sometimes.
We should get into some coding,
yes,
right?
Let's start. So, as I said, I have these views. All these views load different modules. So the about loads the about.js, the contact subsection loads the contact.js, and these files in turn import whatever they need. So the contact has access to the database. To be honest, the database file is empty. It's just to have some sort of dependency tree.
Okay, so you got these. So you've got a one-to-one map. So the contact has got contact.js.
Yes.
And so one of the questions that somebody's already asking is that type equals module versus type equals text JavaScript. We kind of jumped straight over and said, oh, we're using ES 2015 modules. But
I think it's application/JavaScript.
Yeah, but
might be both.
in any case,
Yeah.
whichever way you go, the person here is asking, what does that type equals module mean?
So that is actually super interesting. So when you use modules, you have to set type equals modules, because otherwise an import statement is going to be a syntactic error.
Yep.
So all these imports and export keywords are only available in a module context.
Okay.
And this is how you start a module context. It has another implication, namely that this script tag is going to be deferred by default.
So deferred by default means that if you've got multiple of these, say, modules in order, say maybe you've got 5 of them.
Yeah, if we had like 4 of them.
Yeah, then okay, they're going to execute in order, but at the end of the loading of the page, right?
Yeah, so basically they acknowledge that the default behavior of script tags running right away and blocking everything else was a mistake. So the new type module means do it at the end.
Okay.
And browsers who don't have support for modules will just ignore the script tag entirely because of the type equals module.
Okay.
So there is your hook into progressive enhancement. And that's why the spec also has no module. So if I want to have a version of this file,
yeah, because if you've got all these individual imports and export statements, then you might choose to make a full bundle of everything, where you might actually do something like the code splitting, and you put no module on it. So
browsers with module support are going to ignore this.
Yep.
And browsers without module support are going to ignore this. And so you have control over which file loads which browser loads exactly what kind of code.
Gotcha. OK. So hopefully that answers that question. Let's have a look then. So you're saying each one of those, like contact.js, has a bunch of import statements, which then potentially has other import statements.
So for lols in the miscellaneous, I have misc.js. The misc.js depends on database and video encoder, and video encoder depends on MP4.js.
You know you can like command click on.
No.
Oh, is that because you've got a strange design?
I think it's for the absolute pass, and they're not actually.
No, go back to the HTML for misc.
Oh, the HTML.
Right, just command click on that. Look. Oh.
It's going somewhere wrong.
Wow. Okay.
I didn't know that though. I'll figure out what it is.
That's exciting. There you go.
Either way, so basically, we have multiple ways where the user could come to this website on his first visit. They could land on home. They could land on misc, and have to load a certain number of modules, because this page, the misc was, depends on the on SCView, SRouter app, database, video encoder, and MP4.js.
Yep.
It's like this entire tree of dependencies.
Yeah, and that's specific to that section. But then some of those are going to be shared, like SCView, SCrouter.
Every view is going to depend on these, because every view is a view. So it's going to need the view, the router, and the app.js, which is our general.
And then you've got other specific stuff to that section that comes after that.
OK, so now about the buzzwords. We already have done code splitting in a way, because we have been doing modules and haven't bundled them. So we are only loading the code that we need when we go to a certain website.
Yes.
But what we can do is we can now do the root-based chunking, where we package together things that are needed everywhere in one common JS file to get more.
Yeah, which isn't common JS, like the modules.
No, but it's like the common modules.js.
Head hurts. Right. OK. So
Wording.
OK, like shared.js or this is used everywhere.js.
Yeah, that's probably the best name.
Obviously, naming is hard.
OK.
So
let's start.
Yeah. All right. Let's get into this.
So I'm going to write an NPM script that does this.
An NPM script.
Like a node script.
Why?
Because I don't want to use Webpack, because Webpack already does everything.
Yeah, it does. OK, so you want. OK, so
Webpack is an NPM script, basically. We're just doing our own.
OK, so what you're saying, OK, but you're not doing like a Babel plugin or any of that?
No, we are going to use Babel, but the thing that does the chunking is a script that we invoke.
OK, all right.
All right, so I have an empty file which is called build.js here. Do I still have the thing?
I don't know.
No. OK.
You can hit enter. Tab. Press tab. No, press tab.
I think this is something else, though.
Yeah, you see, that just types out node.
What?
I mean, how have you set this up, my friend? It's all very strange.
Let's move on.
OK.
So my entire build is going to be one function. and it's going to be an async function because we are going to have I/O operations, and therefore we're going to have to await output and input, and so you just invoke this function. And this is a pretty common pattern I keep using in my daily life. But one thing that you have to think about is that if an async function either returns a rejected promise or throws an error, you need to catch that. So if I throw an error in here like this and run the script, I'm the wrong. That's good. GitHub, Google Chrome. There, by the way, GitHub.com/Google Chrome/UI element samples is the GitHub repo where we are going to have this code later on, and all the codes from all our previous episodes as well.
Yes, absolutely. So you can find them all there and have a look around them. Wow, what did you do there to that?
It was too close.
Wow.
Code splitting is the episode. And now if I do build.js, you're going to see this. Let me zoom this in. Unhandled promise rejection, because I'm throwing in my main function. So this is something, whenever you use async function, that you need to think about. And what I usually do is,
so an async function basically says this is returning a promise. So if you throw inside that promise, that's why it says it's a rejected promise.
And we didn't handle the rejection, therefore error message. And also, we don't see a stack trace or anything, which is not really helpful. So I'm just going to .catch it, which is the error handler for a promise, and going to do console.error. And now something tricky, which is error.stack, which will print the actual stack trace of where my error was thrown. So now we have error handling done, which is cool.
So somebody's already saying, is there any point to code splitting? Is it a necessary feature of the web? Yes, I think is the short answer. Otherwise, we wouldn't be here doing this. The honest answer is that even if you best way to put it, you don't want to be sending down loads and loads and loads of JavaScript, OK? The chances are when somebody hits the thing that you've built, there's only one or two actions that they can probably do. In most apps, is like opening a file or just one sort of
interacting with a site nav.
One thing that they probably want to do. And you want to prioritize that code. So you might end up with like a meg or half a meg of JavaScript, which is still a lot. And don't get me wrong, I'd much prefer it if there was less code. But the idea is that this is about prioritization and splitting your code into discrete chunks that you want to ship down. It means that the browser has to do less downloading initially. It has to do less parsing, less execution, any compiling type work that it does under the hood as well. So all these things.
Also, bundling in one big bundle is just super cache inefficient, because any little change to any of the original files will invalidate the entire cached bundle. And the user has to re-download these 1.5 megabytes of JavaScript, which is not good. So code splitting is very necessary and mostly achievable by not bundling in the first place. And then you can do the smarter bundling by doing root-based bundling.
Because the corresponding other bit is that you don't bundle anything, and you have hundreds and hundreds of modules. And that might seem like a good idea, but you've just got to be cautious about whether you're making the best use of the network there.
And this is where the root-based chunking is smarter, because, like as I said, we could just do a bundle per view, but then that means that a bundle for the about section and the bundle for home would both contain our custom elements, which is not necessary. So that's why we extract those in the third module, which is the shared, everybody uses these dependencies modules. So these can get downloaded once and reused instead of re-downloading them every time.
So hopefully that answers the question. Right, let's get back to the code.
All right, so I'm going to write down.
So much chat from us today.
I know.
Code.
Let's write down how this is roughly going to look like. The first thing that we need.
Top down, like it.
I know, right? The first thing we need is we need to know what are the endpoints or the entry points to our website. So
this is because these are the roots, right?
Yeah. So we just need to somehow get those wherever that is. I'm going to implement these functions later, just so we have a way to think about this. Once we have these entry points, we are going to figure out entry points.map, because it's a list of entry points, and for each entry point, build let's go full screen, dependency tree for this entry point, right?
OK.
So now we have the dependency tree.
So these are the modules that need to exist for that particular entry point.
Exactly. It's just like literally the tree. Like for home, these are the dependencies. For about, these are the dependencies.
Okay, yep.
Then we can find out the common dependencies. Find common deps from the dep trees.
I really wish it was as simple as writing out those
I know,
functions.
right? It's like,
This
boom,
is what you
done.
do. Da, 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 da.
So now we have the common dependencies, and then we can build the shared JS, which will be, or let's just call it bundle. We're just going to bundle the common dependencies, right?
Okay.
And turn it into a bundle. And then we are going to entry points for each entry point rewrite. This entry point with the common dependencies, because basically we are removing these common dependencies from their imports and replacing it with one common shared module bundle.
With all of those in. OK, yeah, I think I see where you're going.
So I think this is pretty much what root-based chunking is.
Yeah.
And let's start with
I guess you're going to have to do one by one, right? Extract the entry point.
yeah, so I'm going to do this. And then I'm going to console log entry points, because I want to know if my function does the right thing. So the first thing that we need to do is we need to figure out how to get the entry points. And I thought I would go back to the 90s for this, because what this website has is a sitemap. So if you remember sitemaps, those are used by search engines to figure out which pages to crawl. If you have in the root of your domain, you can have sitemap.xml.
I remember. I think I actually have one.
And there you just list what the pages are. And I have the root, about, contact, and miscellaneous. And we're just going to use this because, you know,
Sure.
why not?
Sure, why not?
So this is going to be an async function because we're doing file operations. So
if you've not done async await and it's brand new to you, then have a search around. You'll find at least one article, I think, by Jake, he goes into some details on what it is, how it works, and so on.
It makes stuff so much easier.
Yeah, it allows you basically to use promise-based async, not surprisingly, but promise-based code as though it's synchronous code is the long and the short of it.
It makes, yeah, stuff like this, file operations, networking, I/O, is just easier to reason about when you don't have the, it used to be callback hell, now it was promise hell, and I think async await is a really good and convenient solution to all of this.
OK.
All right, so the first thing that we need to do is sitemap string is, we need to read a file. So read file app sitemap.xml.
Sure.
XML. So now everybody who's done some Node will know that you need the FS module.
The file system module.
But file system operations use the old callback syntax and not promises. And we are using Node 8, and that means we can change that. Because what they added is promisify from the util module. So
what's the German for promisify?
Versprechifizierung.
I love it.
We should act. Versprechifizierung.
Brilliant.
Yes.
Brilliant.
All right. And what can people might not get it. So let's
No. Leave it.
Leave it?
Yeah. No.
So
I mean, we can always change it before it goes to the GitHub, but for now, I actually want it there. Promisify. Oh, OK.
So what this does is it takes any function that conforms to the standard Node function layout, where the last parameter is a callback that takes error or the result.
Yes.
And turns it into the same function call that returns a promise.
OK.
So what we can do is we can give it fs file read file, and this constant will now behave exactly the same but return a promise. So what we can do, we can just call await here, and that should work. And then we can go sitemap string is sitemap string to string, because this is going to be a buffer, UTF-8. And just for testing, I'm going to return sitemap string and see if it works.
While we're here,
yeah.
In that code, you have the curly. Ooh.
Oh, of course, it's not going to.
Oh yeah, just call it promisify. It's my fault, isn't it?
Promisify. This word promisify is, you know, I can pronounce the German word, I can't type the English word.
There you go.
There we go.
OK.
We're reading the sitemap. That's cool, right?
OK. So you got that back as a string, though, right?
Now it's a string. And now, obviously, this is XML, so we'll have to parse XML. So I'm going to use the good old XML2JS package.
Interesting. So presumably we now need to install that with, or have you?
I've already installed it.
You've NPM
because
installed?
we didn't want to rely on NPM install actually being quick. So
okay.
And the best part is, even though it's an outer module, because it conforms to the structure, we can actually use it on here as well.
So there was a question about the curly braces around Promisify. Did I say that out loud?
No.
Okay, yes, because we reached the bug just as as I was about to ask. So the curly braces there around Promisify, do you want to explain it?
Yes, that is called destructuring. Basically, the require util returns an object that has multiple. So what we could do, this is the same here. Here we store the entire object.
Which is the module.exports object,
so
right?
It's the same as if we called this util and then went util.promisify and did something with it.
Yeah.
But with destructuring, you can basically selectively import, which is more similar to the ES6 import statement.
Yeah, you're saying, I only want this one thing from that entire object, so please just get that object and then pull that one property out and give me that back as this, in this case, Promisify. Yeah.
So let's do this. Sitemap await parse XML sitemap string. And let's return that. And that should hopefully be some kind of structure. Yeah, so it says object, 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 but
I mean, since there are 4 of those and then there's 4 URLs, I'm going to take it on faith that you actually got this.
So now the only thing we need to do to extract the entry points is we are going to go to sitemap.urlset.url.
So that's that, OK.
And then we're going to map those and go to.
So that's each one of those objects.
Yeah, because like we have 4 URL children, so this is an array of URLs.
Sweet.
And each of those has a location .lock. And so if we return.
Ooh, that looks gross, dude.
This should.
Ta-da! I mean, that looks nicer, though.
And now the last thing I want to do is like strip off the domain name. And so you have a URL. Now I actually need URL.
OK, so you're going to parse that URL that you got back and do something.
Yeah,
fun
new
with
URL,
it.
URL, path name.
OK, so that just gives you the /about/contact/ something or other.
Ta-da! And these are our entry points to the entire page. And that is basically our first step done. I want to do a little in-between step where I turn these into the sections, because as I've said in the code, if I say about, I have the about.html and the about.js. So I just want to work on the name about and not on the about.html, because we're going to work on the JavaScript and not on the HTML file.
Not sure I follow you, but keep typing code because I find that easier.
So entry points. .map is an entry point, and I want to now need another module, which is going to be the path. So we can do simple. I want path dot base name of entry point, and I want a path dot x name entry point, and this sections.
Lowercase s.
Yes, you're correct. Look, almost. I mean, this looks pretty good. The only thing that we need to do, tick, tick, and then map entry point. If entry point is empty, then we use index. Otherwise, we use entry point.
Got it. So you're just making sure that empty one at the start. Ta-da!
So these are 4 sections that we need to process.
Okay. So we're making the assumption, which again, in a generalized production setting, you wouldn't make this assumption, is that each one of these sections in the sitemap.xml maps to a .js equivalent. So like about/about has an about.js.
It's true for our test site,
and
not for everyone else.
If you're just joining us, firstly, welcome, hello. We are in the process of talking about code splitting and root-based chunking. What's root-based chunking in German?
Routenbasiertes Klumpen, vielleicht.
Okay. We were just apologizing.
Yeah.
Okay. Okay. The idea being that rather than just saying, go off and use one of these tools, and say Webpack will be, I think, probably the one that most people go to, which is great for production. Absolutely, you want to use the best possible tools for production. We wanted to kind of demystify and explain some of the principles behind the tooling itself. So what we've decided to do is just talk about, if we started with a sitemap.xml and our previous sample with server-side rendering, starting with a site with a bunch of JavaScript that it's importing, some of which is shared between the various sections of the site, and some of which is unique to each section. How do we split the code? What would we actually do if we were going to do code splitting on our own without one of these tools? So that's where we're at.
And root-based chunking.
And root-based chunking. And we're going from there. So we're in the middle of basically reading through the sitemap XML, and that's
we're done with that part.
We've done with that part. So we now know
have our entry points.
Yeah, we have basically our entry points, so the JavaScript files that we know we're going to go
There
after.
they are.
MISC, index, about, contact, and MISC, which is you've
I just
uncommented. There we go.
There we go.
Those are the sections. Great. Okay.
All right. So let's work with sections instead of entry points. So we're going to go with section, section, section. And this is the first time we're going to encounter Babel. So the first thing that we need is our code. So we're going to read file app static section.js.
OK.
So now, actually, that's not quite true, because I always run into this issue with Node where with await, you would have to put parentheses into string in one line, and I don't think it's very readable. So I'd like to break it down in 2 lines, where you do the string conversion afterwards. So now we have the code in a string. And now it's going to get interesting, because we're going to write a Babel plugin.
See?
Yes.
See how fun this is?
Const Babel require Babel core. The core is what we need. And our plugin is. Plugins are, most of the time, I mean, there's multiple variants of plugins in Babel, and the only one I'm familiar with is AST transforms, where you can transform the abstract syntax tree that Babel gives you. And the way it is implemented is that you can implement a visitor pattern. Some of you may have had it in uni, some of you may have not.
That says Vistor. I think you want an I in there.
I might.
Visitor. There we are.
All right. So, and this visitor object can contain functions, or methods rather, for any kind of token type. So the one we care about is an import declaration.
So I feel like it's worth pointing out an AST is an abstract syntax tree, which is once your code has been parsed and tokenized and parsed and everything else, you get this tree, which it indicates all the different.
So you have a program at the top, usually, and you have an array of instructions, and each instruction is like
parameters and all those kinds of things.
Function name, parentheses, parameters.
And so what Babel would typically do would be it would read through your ES 2015-ish type code, because you know it varies, right? Yeah. But it reads your code and it turns it into this AST, and then through a bunch of plugins, it will transform that code into what we spit out on the other side.
And so we're now one of these plugins.
We're going to make one of these plugins that's going to sit between the code that we started with, which, as you said, does actually run in Canary with the flag switched on. Yeah. But we want to do something that would transform it a little bit more. So. Yeah. What we do is we create one of these, this plugin, which has this visitor pattern, which basically means you kind of register these callbacks.
You say, please call me whenever you find an import declaration.
Yeah.
You could also do functions like a string, literal, which you get called whenever there's something in double quotes or single quotes, but we don't want that. We only care about import
So if you look at, there's documentation on how to create these plugins, right? And they will tell you.
I recommend the handbook that we are going to have a link in the description. Where you learn how to write plugins.
So there you go. So we're in the middle of just basically going, we know that we want, whenever we see an import declaration, we want to do something with that.
Yes.
Which is, in this case, we want to build a dependency tree.
So we get the declaration as a parameter.
OK.
And what we really care about is the imported file, which, and I have to admit, I just memorized it, is declaration.node.source.value.
Sure.
Actually, we could just print this out to see that it works. Imported file, and then we're gonna babel.transform on our code, and our options take a list of plugins, and the only plugin is our plugin.
Cool.
This can go. Actually, we can also keep it. It doesn't really matter. We're gonna return something here later. So let's see if this works. Yeah, you see, basically, it now went through all the files. It's a little bit unstructured in the output, but we can see that all the imports that are imported at some point, one way or the other, we get called.
So this is a really great case of you standing on the shoulders of giants is really what it is, right? It's kind of going, I don't want to build an abstract syntax tree myself. I don't want to.
Or you want to fiddle with regular expressions trying to parse JavaScript.
This is tried and tested code. This is great code. and we can make use of it, as you say. We just hit that import statement, and we can just kind of go, what imports are we actually seeing here? So this is really cool. OK.
And what we want to do, really, is we want to collect the dependencies. So I'm going to do an array.
Stateful.
Yeah, a little bit. Yeah. I'm not sorry.
No, not even a little bit.
And I'm going to push that dependency on our imported. I'm going to push the imported file onto our dependency list. And that dependency list is what I'm going to return. And now that means that our dep trees should now be an array.
Which should look pretty similar to what you just did.
It is a promise. That is true. So I am going to await promise.all.
OK. And now?
Boom. So now we have
an array of arrays.
This is the home root, where we only depend on 3. This is the miscellaneous root, where we depend on 4. But if you take a closer look, you will see that the MP4 counting. But the MP4.js is missing because we are not actually looking at the dependencies of our dependencies. We're not going down the entire tree.
So this is just the first level?
This is the first level of dependencies.
OK. So can we fix that? Is that possible?
Yes, we can.
Yay!
So back to our. Basically, what we just need to do is we just need to call this.
So we're kind of recursively calling down. We see an import.
Now, it's a little bit tricky. So because we now have to do another I/O operation, which is async, but Babel is inherently synchronous.
Oh.
So something you can do is just do an anonymous asynchronous function that you invoke immediately to kind of do it async. And then in here you do no, that's not true. Const code is.
I'm glad you know what you're doing, because right now I'm watching this going, I mean, it's a complete mystery to me.
Imported file. So
what are you doing?
In this async function, we're going to read the imported file and then call our plugin recursively. So reading that.
Sure.
And we're doing that.
So I get that you're OK. Interesting. Do you not have to await anything on that function that you're calling immediately?
No.
OK. All right.
I think this is fine.
Should we find out?
Yes. Let's find out. But we need to, but now we have one problem which we can fix. Ooh, this is good. I can plug my side project. So surma.github.io/underdash. The thing is that we are now we're putting more arrays inside our arrays, so we want to flatten it.
Yes. OK, because we don't care. All we care about is getting a kind of a top-level list of here are all the imports.
All dependencies. And there is no default flatten on an array in Node or JavaScript. And so you can go to my project, which is called Underdash, where all these little useful functions are there for you just to copy.
It says right there, just copy-paste what you need.
Yeah, so if we need flatten, we're just going to go with this.
Hey!
Just going to copy that.
Oh, look at that.
We're going to paste it down here.
Of course you would. Why wouldn't you?
And then
you're going to flatten the depths?
We're going to flatten await promise.all.
I don't even know why you're doing that, but OK.
Because there's still promises in there.
So definitely when you said it was easier to read the async await code. See? I was wondering whether that.
Oh.
Yeah.
This is sneaky, I think.
Is it?
Yeah. OK. Listen. As I said, Babel is synchronous. So this async function is going to get actually executed after all the synchronous code is done because it's a microtask.
OK.
So we need to push something onto dependencies right away. So I'm now going to.
That's what I was going after. I was thinking you need to do something that says there's something coming in here that will need to be processed later, or.
Actually, we are going to return await. This is so much cleaner. Dependency tree. Now this makes much more sense, doesn't it?
No.
No?
No. What are you doing?
So
do you not need to pass that something?
Yeah. What we're going to do is we're going to pass the imported file, but that we need to turn this into a file. So.
Oh, so you need to call that with the initial.
So we're going to put this here instead. This is a file. We're going to read that file. Now we have a function that returns all dependencies of a file, and we can just.
And then recursively goes down and finds the next one. OK. Should we see if that works?
I'm a little bit wary, but.
Ooh.
That is correct, because it is a /static path, and I need to anchor it to my app folder where all these paths are.
All right. Yeah.
Hooray!
Now, do you still? Oh, you have MP4 now. So
because now we're actually recursing down the entire
so we have
tree.
the dependencies of the dependencies, which in theory could have the dependencies of the dependencies of the dependencies.
It would go down all the way.
It's all the way down. OK.
All right. Now, this is actually step 2 done. We have built a function that builds a dependency tree.
Yes.
And recurses down. So now we can go on to the next step and talk about figuring out what the common dependencies are.
Oh, no, I feel like this is, you know, should be.
How would you do it?
I mean, interesting.
Right?
Yeah.
So find common dependencies from our dep trees.
How would I?
If you literally think about the trees,
thinking.
All you really want to do is just find nodes that appear in all of these trees.
Yes.
So what we're going to do is...
Are you going to do like an n-squared-y type thing where you take a node and then look in all the other nodes?
I don't even care what the runtime is, because this is not production-ready code.
Oh, no, as soon as you don't find it, the worst case would be n-squared.
I think so. So I'm going to flatten the tree into a set. And then for each item in the set, I'm going to check if it's appear in all the trees. And if so, keep it. I think code will be better to visualize.
I know where he's going, which is just as well.
So we're going to do a new set.
Yes.
We're doing JavaScript sets now, because then we don't need to worry about filtering out duplicates. Set does this for us.
Yes, if it's in the set.
So dep trees for each, which is one dep tree. So for each
that's like the one that's for home, one that's for about, one that's for contact, one that's for MISC.
And each of the dep tree has, for each, has a dependency and dep set at dep. That's it.
So the folks are on the chat. Hello again, folks on the chat.
Hi.
I'm really enjoying watching all the chatter go by. And there's a lot of people kind of picking up the fact that we're going for sets. And I think some people it's the first time they're seeing them. So that's really exciting.
They're really fast.
They're very good, really useful, primitive to play around with. So, and for this kind of situation, they are actually quite useful as well. So.
It's just easy to grasp. You're like, oh, it's a set. There will be no duplicates, because that's how a set is defined. You can't have the same thing twice in a set.
Yeah.
And we just want to have a list of all dependencies that appear. That's a set.
Can you not make a set from an array? Can you not like?
I might. Let me just check first if this works.
OK.
This looks like all the dependencies.
I mean, for this number of dependencies, it's not a big deal. And probably for most projects, unless you've got thousands of dependencies, this would be micro-optimization. So carrying on. It was just me being curious. And
so now we have a set. And what we want to do is we want to turn that into an array and then filter on it, because we want to filter out the things that do not appear in every tree.
OK.
So for each dependency, we want to check if for every dep tree includes does not include this dependency. Let's do this explicitly, because otherwise it's going to get too noisy.
No, you want to you want every tree to include this dependency, do you not?
You want to filter out the ones that. Now I'm actually not quite sure. Let's try both. Yes, you're right. We want to keep the ones that are in every dependency tree.
Yes, that's why we call them the common dependencies.
I think I have to go. Thank you for coming. So, as you can see, now we have a set of dependencies that appear on every entry point. And that is correct, which is amazing.
Yeah.
And this is actually 5 lines, which sometimes it amazes me that you can express things that are harder to explain with words in like snappy snap snap code.
And do you know what? Some of these newer, they're not new, but they are newer, definitely operations, for want of a better term, I suppose. Methods on the arrays and so on are hugely significant, I think. Filter, find index, map, reduce. Like these are all
reduce. I use reduce a lot, but I still feel tricky using it. Like I feel like I'm not actually easily conveying what I'm trying to do. Yeah. I like it for like promise chains. We could chain together promises.
You reduce the chain down to a single.
I feel smart doing it, and that's usually not a good thing.
No,
it shouldn't feel smart.
In a few months, you look back going, what was former me thinking?
Exactly.
Yeah.
OK. We now have common dependencies figured out. So now let's bundle these common dependencies into one module.
OK.
Right? So what are we going to do? We are going to write that function. That is what we're going to do. We're going to write the bundle function. Function bundle. And bundle is going to take a piece of code. And this is interesting because
what are you doing?
I'm just going to quickly generate some quick and dirty code because that's just, I think it's easier to do.
OK.
So
hence if you're just joining us, we're making our own code splitter. Because why not? Because we wanted to just talk about the kind of things that go into code splitting. And it's not production code. We always want to be very clear on that in what we do in Supercharged. This is very much about us sort of sharing a journey and a process and an idea or concepts. And sometimes the code, it's a good starting point for something that you might end up doing in production. But certainly something like this, we are...
If you want to put in a lot of work, you can productionize this.
Yeah.
But there's still work to be done.
There are existing tools that already do this.
Well-known tools, well-explored tools, tested tools.
Yeah. Rather than...
Reinventing the wheel is usually... should be avoided.
Unless you want to learn about wheels, which is exactly what we're here for. So let's carry on.
So I'm just going to console log the old code, the code that we are generating, just to see that I'm actually doing the right thing, and comment you out. So
old cold. Old cold. There you go.
Oh, it's just the old code.
It's the old cold. Gets me every year. OK, so this is...
that is what I actually wanted to do is I wanted to join this with a new line. So we should now have pretty much an empty file that just has 3 imports. So this is now the file that we want to roll up, basically.
OK.
So we're going to write our own Limple roll up real quickly.
Sure.
Where we're just going to import all these files that we need.
OK.
Sure. And we're going to do that with a Babel plugin. Woo! More Babel plugins. So we're just going to copy and paste the old stuff. And for each, so we're going to have new code is an empty array. And for each imported file, we are going to, let me think for a bit. Let's remove this. So we are going to read that. No, we're not going to read it. We're going to go recursive again. So we are going to bundle, await, read, file, app, imported file. And
tell me what you're doing here.
OK, I'm going to explain it.
OK, I'm good, because I don't understand it.
So this plugin for Babel is going to take a file. And whenever it encounters an import, it's going to remove this import with declaration.remove, which removes that import, and then inline that imported file. But before doing it, it has to do, again, the recursive thing where it does
right, so if the thing that it's going to replace has imports, it needs to replace those calls itself. OK, all right.
OK, so what it does...
You have a new code array at the top. Do you need to do something with that? Because you've got declaration to remove, but presumably you want to push...
New code. This is where we want to push. So we want to push it in. And now we're going to have to do something new. So because before we just ran Babel, and as I said, Babel does code transform, but we totally ignored the output beforehand.
Well, we take it and do something...
No, we take the code, we do a transform, and then we ignore the result, which we now actually need, because we want to have the code that is without the imports.
So you're destructuring again to get at the actual code?
I'm getting to the code, and now we push that onto the array as well. And then we return the await promise.all new code. We're going to flatten it, and we're going to join it with new lines.
Wow. So there's a lot going on in there. And before you go and run that, so the reason you're doing promise.all around new code is because some of it will be a value, a literal value, but some of it will be a promise, like the call into bundle again. So you've got a set of, or an array of, some literal values, some strings essentially, and then some promises. So what we're doing is we're saying wait till at least all the promises inside that array resolve, and then we'll have an array of literal values at that point, which we can then. So you're waiting on that happening. Then you're flattening any, because you've got that recursive kind of thing going on. So you flatten all that down, and then
it's just an array of strings.
And then you join those with new lines so that at least it's tidy. Yeah. Yes. OK.
So let's try and see what happens. Share.js. If we print this to the console. No.
No, it's missing a
Oh, because
Paren.
I made. No,
it says it's waiting.
Yeah,
now.
because await is.
Go on then, let's see what happens. I'm happy to trust you. Code's not defined.
Which line? 39.
Now, somebody's asking, what if the imports are circular?
Oh, this one. Old code.
Surma.
Yes, I heard the question, and I'm going to ignore it.
So are you basically implying at this point that we are not considering circular code?
We are not considering circular dependency.
Which is what I assumed we weren't as well. But again, this is another reason why you'd use
like
another tool.
Rollup has figured that out. I think Webpack as well.
I
mean, I have an idea of how you could do it. If you were to use bundle, you would probably have something like already imported dependencies as an array and skip the ones if it reappears.
It's a graph theory type moment where you say, I've visited this node, don't revisit this node. So
I like this is usually we try to keep it, that people can follow along. And I thought about it, and I purposely did ignore it because it was just it's out of the scope for.
We're ignoring it, I think is
something that. So as you can see, we now have. Whenever there's a copyright header, this was a separate file. So now we have concatenated multiple files into one, which is cool. So now the only thing we need to do is write that file. So I'm going to await. Oh, now, we need another one, because now we need write file. What did I do?
I don't know.
I pressed the magic shortcut. So write file, and then down here we can write file, which is going to be app static. I'm lazy. I'm just going to say all generated files start with an underscore.
OK.
Because why not? Shared Jazz. And let's go back here. Let's run it again. Should be nothing. And then in app static shared. Boom.
OK.
And now, for the final step of this journey, we have to rewrite our entry points. Because right now, yes, we generated shared JS, but nobody's using it.
Yeah, everybody's still back at the original set of imports that they had. So every time we presumably find those imports together, we should be able to replace those with what you've got here in that shared JS.
So async function. It's going to be async because we have to write files. There's going to be I/O. It's going to be async.
OK.
That's the logic I usually go through in my head. I think we have, for example, the find common depths was not async because we're just working on the tree that is already there. No reason to make it asynchronous. Rewrite. We're going to rewrite, actually, not entry points. We are working on sections. Section. We take a section, and we take the common dependencies. Because what we're going to do is we're going to write a third Babel plugin.
Wow, you're just all up in that.
Yeah, so that's also a thing. You probably normally wouldn't do that, but I'm not an expert in Babel. I just threw Babel plugins together and do 3 passes. It's not efficient, but it works. But it conveys the concept.
OK.
Did I say it's not production-ready code?
We may have covered that.
All right. So what we're going to do is we're going to go through all our sections, each individually, and basically remove all the imports that are already in the
shared one. Yes.
And then we're going to prepend an import for the shared bundle. And that should work. And let's figure that out. All right. So I'm going to do something I've done before. I'm going to copy my plugin.
If nothing else, this is, I think, showing why some of these tools exist, right?
Yeah,
because
it's hard.
Because writing some of this code is, it's pretty challenging.
Yeah.
And yeah.
The cool thing is this one is actually one of the easiest plugins. So what I can do is if common dependencies includes imported file, then we remove it. And that's it.
So, OK.
So we have the dependencies. Common dependencies is a list of modules that are.
OK, so like the scview.js. So you're saying if this file contains that one, get rid of it. Because we should know that it's a common dependency because we've already figured that bit out earlier. So we can be safe to remove it. OK.
So now we're going to actually run the plugin again. We're going to transform our old code. We're going to need to read the code first. I forgot about that. So const old code is await read file app static section.js.
Somebody's caught a bug for you. Const imported file includes imported files.
Thank you. That was a quick turnaround.
I know, right?
Yeah, thank you very much for that. I always
Thank you.
appreciate a good bug fix. We are reading the code. I have to do the thing again. Old code is old code to string. Also, not very optimized. I'm reading the same file, I think, the third time now, which you usually wouldn't do. But
OK.
We are removing all the imports. This will be the code without the importer in the shared module.
OK.
So we are going to.
Now we need to prepend our.
We are gonna. That means, you know, let's let it again. Let's make it a let so we can know. And then we can say code is import. No, let's do string literals because I'm gonna need the single quotes. Static shared.js is what I called it, right? Yes, shared.js up here. And I'm gonna prepend the old code. Even gonna give it a new line. I'm nice like that. And then we're gonna await write file app static section.
OK, so you're now rewriting the about.js to
with
include.
an underscore, because all my generated files start with an underscore.
OK.
Right, so code. And this we're gonna have to await promise.all.
Why?
Because each of the rewrite functions will return a promise until the writing action is done.
Didn't need to map it then instead of for each.
That is correct. Look at you.
Hey, you know, occasionally I have my uses.
So this should not output anything, flop, but we should have app static
About.js?
about.js, which just imports shared.js, which is correct.
Yeah, and then was it MISC that had that plus the other two?
Flop.
OK, so yeah, so it's doing its job. It's doing exactly
it's
what
a little bit hard to read because there's the two imports.
But you've got that shared JS at the top, which is the ones that are shared, obviously.
Yeah.
And then the two that are specific to that section. So we've effectively figured out what's common, put that in its own file.
Yeah.
Was that shared JS that was flattened, right?
Yes.
So that's all been flattened. Somebody pointed out as well that we don't do anything about sort of conflicting variables or whatever across those shared.
Exactly. We also don't support the import sub-object from. Whenever you have these kinds of imports, this would already break. So
yeah.
It is production ready.
No. There's only so many times you can say it, right? But hopefully you are getting the idea. You're seeing, you know, to be fair, you are seeing like async await. We're seeing promisify. What else have we got in here? Obviously Babel plugins. There's loads of stuff that's in here. Yeah, of course. You know, there's all sorts of interesting techniques and ways of thinking about these problems even if you just try some of this stuff yourself.
And I do recommend sometimes doing the top-down approach that I did. You write down a sketch of the calls you want to make in what order and what data you need to move from A to B to get to your goal. And then you go down the rabbit hole. Naturally, I'm a person who starting with the individual puzzle pieces and then tries to build a house. And sometimes I have built a number of functions I'm never going to use. And this way, it's easier to walk towards a goal.
That's Underdash, isn't it?
For example.
But nonetheless, so even though we're pointing out, yes, it's not production ready. Yes, there's lots of edge cases that it doesn't handle. Hopefully, you are seeing some of the ideas and the concepts that are at least would be behind a professional tool. And you can see why people have spent so much time and energy to put these high-quality tools together in the first place.
I mean, there's basically only one thing left for us to do.
No.
Which is showing that it actually works.
Now, at the moment, your HTML refers to the
non-generated version.
The non-generated
so all I
version,
have
the
to do
original
now
one.
is to go through this HTML and add an underscore, really. And that should make us flip over to the new generated versions that have root-based chunking.
OK.
So I'm going to go to Canary. I'm going to go to the router. I'm going to open DevTools. And I'm going to look at the network panel.
OK.
Because we want to see.
So we should see shared JS, should we not?
Yes, let's see. Yes, we're going to see the index.js and the shared.js, which is all the index file really needs. And if we go to miscellaneous, we should see the miscellaneous.js, the shared.js, database, video, and MP4.
Yes.
In this case, it only loaded the ones that were not already there. But you can see we've switched pages, and shared.js wasn't reloaded.
But this is a nice feature of the the modules, right?
Yes.
The modules are automatically kind of handling this idea of, oh, I've already got this import. Why would I get this a second time?
Yeah.
But we've made the most of that single import now, because in that single import, the shared one, there's actually a lot of code. So it's sitting somewhere in between. I have an individual import for every single part of my app, which could give you hundreds, if not thousands, of imports. Versus,
and also, it can get really bad in terms of loading time, because the browser won't know what to fetch next before receiving the first one and saying, oh,
no, there's more in there.
Dependencies. I need to go out to networks and grab those. And then and round trips are really expensive.
So what we're saying here, I suppose, is that on the one hand, you could have this big bundle, which is what a lot of sites are doing today. And this is where we've come from. On HTTP 1 in particular, you would bundle everything into app.js, and that's it. And it serves every single part of your app. And sometimes those are huge. We know that people have a lot of functionality they're trying to pack in today to their stuff. So that's the old way, if you like. You could go completely the other direction and be like, I've got thousands of imports, but that can be, as you say, suboptimal.
Which I do during development. On localhost, that's fine.
Yeah.
But in production, that is gonna tank your loading.
And what this is doing is it's bringing us back into that sort of mid-ground.
It is a spectrum. It's not always black and white. You can
exactly, and it's going to really depend on your context as to how far you can push this. And obviously, while we're doing this today specifically for our particular app, you want to investigate ways to do some of this stuff in your own code for your own app.
Something we haven't done that is something you could add on top is another buzzword is tree shaking, where you remove the bits of code that never get used from your modules, because sometimes
that was the buzzword dance that I was just doing there.
Oh yeah, we have a buzzword dance now apparently. Sometimes some projects, even though they are already in modules, still have here's all our formatting functions in one module, but you only use one of them. And tree shaking is the process of removing all the code that never gets called into.
And again, if you think this was a bit challenging,
look into that. That is
tree shaking is, I think, is out there, isn't it? So
yeah,
cool.
That's pretty much everything I wanted to talk about today.
Awesome. So with that said, thank you very much to everybody who's been joining us on the live stream and in the chat.
Thank you so much.
We've had a blast. It's really nice to be back. And I guess till next time, I've been Paul.
And I'm Surma.
This was Supercharged. See you later.